Right, let's have a look at this circuit. We have a 9-volt battery. We have an ammeter displaying the total current to the circuit. We then have two individual ammeters in parallel to two resistors of the same value in parallel. So the current will go along, passing through the first ammeter. It will then separate depending on the value of each resistor, and so much current will go down each of the parallel lines back round to the negative of the battery. So let's look at calculating the current passing through the first ammeter, which is the total current in the circuit. So we need to first calculate the total resistance, because it's the combined current. So it's 1 over RT plus 1 over R1 plus 1 over R2, because that's the formula for parallel resistors. So let's put it into the calculator. So I usually do brackets, so it's bracket 1 divided by 1000 plus 1 divided by 1000, also in brackets, equals 0.002. So we haven't finished there, so 1 divided by 0.002, and that gives us 500. So you'll note here, because we have two resistors of the same value in parallel, then the total resistance is half the value of 1, and that only works for two resistors in parallel. So total resistance is 500 ohms. We want to find the current, so it's 9 for 9 volts, divided by 500, it's in ohms, so it's 500 ohms, equals 0.018. Move the dot along a few and we'll get 18 milliamps. And if we make the circuit active, you can see the ammeter here displays 18 milliamps. So the total current in the circuit will be 18 milliamps. So what about what current will be down each of these parallel lines? Well, each resistor here is 1 kilo ohms. So let's put that into the calculator and figure out how much current of the 18 milliamps is going down the first parallel line. So it'll be 9 divided by 1000, because it's 1 kilo ohm is the value of the resistor, equals 0.009. Move the dot along, it gives us 9 milliamps. Okay, so again, it's the same value for the next parallel line, it's the exact same calculation, so that will give us 9 milliamps. 9 milliamps plus 9 milliamps gives us a total of 18 milliamps. So we know, because these values are both the same, and it's 2, because it's two parallel lines, then the total current, 18 milliamp, is merely halved along each of the parallel lines to give us 9 milliamps. And that's how we work out the current in the parallel circuit. Alright.